Yes, it's YouTube Live.
Hey.
Like, subscribe, and save, please.
Save.
Support my advertisers.
Wait, do you get paid?
No. I don't have my videos monetized. Maybe I should. Raking some extra cash on the side. All right. Have the textbooks open, please. Open textbooks to page 195. 195. So you have problem set 48 in front of you. And I'll open it up for any problems from the homework that you want. Remember, you have a test tomorrow. 48. So it might be a good idea. Actually, it would definitely be a good idea to go over some problems that you weren't entirely confident in.
Up to 44, right?
Up to and including 44 for the test. Yes.
Test is up to 44.
Yes.
You got the problem set.
Say it again. 5 and 6.
Yeah.
Now 5 and 6.
Okay, there.
5 and 6. We this is a new type of problem, so these won't be on the test. But yes, so 5 and 6. The only thing that's different about these is setting them up is slightly different because we're dealing with percent. So someone read number 5 aloud for me there.
What percent is 60? What percent of 60 is 88?
What percent of?
160.
Of 160
Right.
equals 88.
Okay, what percent of 160 is 88?
Which means WP times 160 equals 88.
Yeah, so our variable, our mystery value of 160 times 160 is 88. It doesn't matter when the mystery thing is a percent, a fraction, a decimal. It doesn't matter. You can always set it up just using x or n or whatever you want to use for your variable, for your mystery quantity. So whether it says what percent, what fraction, what decimal, what portion, it doesn't matter. We're always going to use x. What percent of times 160 is 88? Now, how are we going to solve this?
You can divide 160.
Yeah, we're going to have to divide out 160. 88 over 160. Can we simplify that fraction at all?
Yes.
Yes.
You can make it 80 over 20.
Say it again?
11 and 20.
Yeah, 11 and 20 would be the best. We divide, no. Yeah, we divide them both by 8. 11 over 20. Divide them each by 2, then we get 44 over 80. Divide them each by 2 again. We get 22 over 40. Divided by 2 again. Get 11 over 20. 11 is prime.
11 over 20 is 55%.
Now, we have to convert it to a percent. If you give me this as an answer, that's mostly correct. It's not quite the right format. This would be like a -1 here. If you give me this. Because they asked for a percent, not a fraction. So how are we going to convert this to a percent?
Wait, I have a question.
Yep.
Like,
Oh,
for one of them, the answer was 9, like you said 0.9, I think, and I put 9 cents for this fraction.
That would probably be fine.
Okay.
Usually, the problems involving decimals, we're going to stick with decimals. But here, let's convert this to a percent.
what I did since it was 20, I just times it by 5 and like top of 1.
Yeah, so remember with our fractions, a percent is a fraction that has what on the bottom? 100. So if we want to convert this to a fraction that has 100 on the bottom,
Multiply by 5.
we multiply the top and the bottom each by 5. Remember, we're always allowed to do that to a fraction. We're always allowed to multiply the top and the bottom by the same thing because it's a way of multiplying by 1. So we get 55 over 100 or 55%. Yes? What? You were here like half an hour ago.
Exactly, man. P.
Hurry up. Hurry up. All right, let's do number 6 also. This type of problem is worth going
Go
over.
ahead, Logan.
Will you stop?
What happened?
If 25 is increased by 140%, what is the result? Now here, this one, we're actually going to have to rephrase it before we convert it into an equation. So, if 25 is increased by 140%, what is the result? How can we rephrase that?
25 is increased.
It's increased by 140%. So what are we looking for? What percent are we actually looking for? If we're increasing it by 140%.
60.
What percent are we increasing it by?
40%. 25 is 10.
What percent of 25 are we looking for? If we're increasing it by 140%? No.
Oh, 40.
Like between 25 times 2 and 25 times 3, like between.
Yeah, it's going to be somewhere between twice as much and 3 times as much. Because we're increasing it by how much?
40.
No, we're increasing it by what?
140%.
So what percent are we ending up with if we increase it by 140%? Right. We're actually looking for 240% of, I can't remember the number,
25.
of 25. Thank you. This is really what they're asking, is what's 240% of 25?
Yeah, you're supposed to know this.
Because that's what increasing 25 by 140% means.
Oh, because like you're
Because 25 is 100% of 25. Yes?
Yeah.
If I'm increasing it by 140%, that means I need to add another 140% on top of the 100% I already have.
Mm-hmm.
Yes?
Yeah.
Yes?
I get it.
Yeah.
Okay. Because we want 100% of 25, and then we want to increase it by another 140%. So we actually want 240% of 25. So how are we going to set this up?
240 over 100 times 25 over 1. Yeah. And
Okay,
then you can
let's,
simplify 100 by crossing it out and putting 4. And then you get 4 over 1, and then the answer is.
we can simplify it again before we do this.
24 divided by 4 is 6. It's 6. 60 is going to be the answer.
Yeah,
So the x equals 60.
60.
Wait, this one,
Yeah?
I just, can't you just figure out what's 40% of 25, and then add that to 200% of 25?
Yes. Yeah, you could do this a couple different ways. This is where we combine it all in one step. Here are other things you could do. You could find out what 140% of 25 is. You find out that it's 25, and then you add that to 25. You increase it by that much, and then you get 60. You could do that. You could also figure out what 40% of it is. You figure out that 40% of 25 is 10. And so we need 200% of 25, or 50, plus that other 10, that other 40%. I think it's easiest, though, if we can bind it into one step as much as possible. Because then we only have to do the multiplication once. We don't have to add anything else onto it. Yes?
Yeah.
Okay. Questions about either of these? Or any other problems that you want to...
Where did you get this 60?
We're going to 60 because, so first we canceled out the 25 up here and the 100 down here to 1 and 4. Then we cancel out the 4 and the 240. Divide them each by 4. 240 divided by 4 is 60. 4 divided by 4 is 1. Yes?
Mm-hmm.
Okay. That's what I can.
If you're like for like a different problem, say it would be like increase like 40 by 300%, it would be like 400% of.
Yes. Yeah, if we're increasing it by some amount, that means we're adding that much percent on top of what we already have, which is 100%. Yes. All right. Any other problems from the homework that you want to go over? I'm hoping there are.
Oh, yeah.
Well, I'm hoping either there are or you guys all ace the test tomorrow.
Number 10.
Number 10, all right. Yes, number 10. Number 10 was skipped. But number 10 is a good one to review, not now, but if you want to come after school and go over 10, because number 10 you can't. Number 10, we're dealing with mixed numbers, so first you're going to have to add 4 3/4 to both sides to get 3 3/5 x by itself. Then you're going to have to divide by 3 3/5 on both sides. So you have to make sure that you're confident with your mixed numbers and your fractions and adding and subtracting them and all that. Just put this away. Oh.
No, please.
Why don't you go wash your hair? Wash your hands.
So I was gonna.
Wash your hands. Go wash your hands.
I got here.
Go wash your hands. Using my soap. Rub. Get nice and clean.
Can I get my paper back?
Maybe.
I'm gonna say.
Alright, other ones from the homework you wanna go over?
Number 11.
Soap and water, please.
Yeah.
What?
11.
11. Yes, alright, 11. 0.2p plus 2.2 plus 2.2p equals 4.36. What's the first thing you have to do here? I look at this problem and I see something I hate. I see something I hate. What do I hate?
Decimal.
I hate decimals. They're stupid.
I did the whole.
Don't let any Europeans tell you otherwise.
Wait, what?
Huh?
I
What?
did the whole thing in that.
Don't let Mr. Stolman tell you otherwise. Mr. Stolman and I had an argument right before Christmas break about imperial versus metric system. So he's spent a little too much time in Europe.
Ours is called.
Now I'm trashing him on the internet. Man, this is bad. He's gonna come. Anyway,
We're like a drama lord.
I'm sorry, Mr. Stolman. I didn't mean a word of it. Okay. Anyway, some people really prefer decimals. I don't. Why don't I like decimals? They're hard to do algebra with. So what do I do first?
Get rid of it.
Yeah. How can we get rid of these decimals?
By not doing problems.
Okay, but imagine we want to pass the class. We want to know how to do this.
Moving the decimal 2 points over.
Right, we're going to have to move the decimal in every single one of these terms over 2 points,
You
2
get-
places.
So you get 20p plus 22, with plus 20,
This
one- 220.
This one is
Plus,
so easy to do.
uh,
Exactly.
220p.
Right, so notice we move the decimal place 2 places over on each of them. So 0.2p becomes 20p.
20p plus,
2.2 becomes 220. 2.2p becomes 220p, and 4.36 becomes 436.
220p plus, 10, is that 10? I think. 2p plus, 20 equals, 260p.
No. We got 20p and 220p.
So it becomes 240.
Right, so we can combine our like terms. We get 240p. Using the command.
And then you can subtract 220 from, you can,
I wasn't trying to cheat. I was just trying to study it on my head because that's the one I don't know.
and then you,
I know every other one.
Yeah, so we can combine our like terms. 20p plus 220p gives us 240p.
then you can
Subtract 220 from each side. We get 240p equals
That one.
Oh, I gotta take notes on this.
equals.
216.
Yes, 216. Now what do we do?
Subtract, divide,
Divide by
216.
no.
240.
By 240 to get p by itself. All right, 216 over 240. How can we simplify that?
9/10.
Okay, yeah,
I
but
didn't get that.
how do we get that? You look at this. What can we obviously divide by?
1 and 6,
8.
4,
4. We can definitely divide by 4. Maybe we could also divide by 6. That would be cool.
12.
Yeah, we could do 6. How can you tell that we can divide these each by 6?
Because they have 6.
No.
No, they have multiples of 6.
How can we tell that we can divide both of these by 6?
because they both,
Because when
if
you
you
add
add
them
them
up,
up,
they get
both, they
6.
both are a multiple of 3, meaning that they're divisible by 6.
Not
Well,
If
necessarily.
you add 2
them up,
plus
they
4
get
is 6, and then 2 plus 1 plus 6 is 9.
So remember your rules. Remember your rules for telling what number, for telling whether you can divide a number by some other number. Whether something's divisible by 2, that's easy. How can you tell whether something's divisible by 2?
It ends in an even number.
If it ends in 0, 2, 4, 6, or 8. Yes?
Yeah.
Okay, now 3, we talked about that rule yesterday, I think. If we add up all the digits and we get something divisible by 3, then the whole number is divisible by 3. So it's 216, you add up those digits, you get?
9.
So is 216 divisible by 3?
Yes. That's what I said.
Add up 240,
You get 6.
you get 6, that's divisible by 3. So these are each, not only are they divisible by 2, but they're also divisible by 3. And that's how you tell whether you can divide something by 6, is whether you can divide them by 2 and 3. So let's divide them each by 6, what do we get? What's 216 divided by 6? Well, what 6 goes into 2 how many times? Don't just say I don't know, let's do it.
It goes into 21,
3.
3 times with how many left over?
3.
Okay, it goes into 36 how many times?
6.
Okay, 6 goes into 240 how many times?
10.
40.
4.
It goes in 40 times. Yeah, it goes into 24 4 times, then 0 times into 0. All right, 36 over 40, what can we divide those each by? Well, we can definitely divide them by what?
4.
Yeah, 4, also 2. If nothing else, you should be able to see you can divide this each by 2. What's the rule for telling whether we can divide something by 4?
It ends in 4.
Things are divisible by 4 if the last 2 digits are a number that's divisible by 4. So if the last 2 digits are, look, 16. 16 is divisible by 4. 40 is divisible by 4. We could have divided these each by 4. We could have divided them by 12. Or actually 24. Anyway, 36 over 40 divided each by 4, we get 9 over 10. Ideally, now I'll take that as an answer here. I'll give you full credit for that. But ideally, because the original problem has decimals in it, ideally our answer would also be given in decimal format. So write 0.9 rather than 9/10. But 9/10 is fine.
Man, I did this whole problem without doing without moving.
Without what?
Like moving it over.
Decimals are.
You can do that. You can do that. If you want to, you can do this problem without moving the decimal points. It's just annoying because you're going to have to add and subtract and multiply and divide things with decimals, which is annoying. And we make mistakes. So let's not do annoying things where we make mistakes.
Yeah.
Let's do easy things where we get things right. All right, Next. next problem we want to go over. Next problem we want to go over. Any others? You guys feel really confident for this test tomorrow?
I remember
Okay.
I'm trying
No,
to
no, wait. Number
do
7.
number 3.
Numbers.
Wait, I'm gonna get my other study guide.
Which one's 7?
7.
That one's easy.
Okay, 7. Now this is not on the test yet either.
Oh.
But 7, notice, 7, we're describing this graph here, where the graph is showing us the solution. So x is what? Has to be what 2 things? It has to both be what?
Equal to -2.
Okay, equal to -2 works.
And greater.
Also greater than -2 works. What else? But not everything greater than or equal to -2 is going to work. What else? What other constraint do we have here? It's also got to be less than 3. That's how we write it. When you've got one of these where it's got ends to it, 2 ends to it, you're going to need to write a conjunction. You're going to need to write 2 inequalities. And the way that we do that, just for convenience sake, is instead of writing this, you could write that. That's true, but this is the format that we want. Between them.
That's not gonna be.
This is not going to be on this test, the next test. That'll be on.
Well, wait, when we do tests, do we do it by like every 4 problems then?
Yes,
Can you tell me how many orders?
not yet,
Why?
because we haven't done 49 yet.
Why did they do 49 if there was tests?
Well, because you guys don't seem to want to do any review, so we're going to do 49 and then we'll stay on track. We can spend the rest of the class doing real review, or we can continue to 49. It doesn't matter to me which we do.
Review.
Okay, great. Open it up. If you want, you can look back at lessons 41 through 44, which are the newest lessons on this test, and see what things you want to ask about, you want to go over. What about it?
You go over it. What can we do a problem from?
You want to be a little more specific?
We do number.
Number 33.
That's 41, Tom.
No, it's 6.
That's 47, you idiot. That's not even gonna be on the test.
No. 40. On this, on problem set 44.
You guys have about 30 seconds to come up with something real to ask, or I'm going to continue to 49.
3.
From what?
Lesson step 48.
48, number 3. Unit multipliers. Okay, yes.
Alright, is that gonna be on the test tomorrow?
Yeah, unit multipliers are going to be on there.
Oh.
Unit multipliers are always on there. All right, number 3. Yes, 6 unit multipliers to convert 28,000 square inches to square kilometers. Now, this is going to be annoying because we're going to have 6 unit multipliers. The process works the same. Walk me through this, somebody who knows how to do this, who feels confident
28,000 inches over 1.
Okay, we'll start by writing this as a fraction. 28,000 inches times inches over 1. Okay, then what do we do?
What are we, kilometers? Okay, so.
We're going to kilometers.
So then you need to go to, centimeters.
Yeah,
Yeah, so,
So what am I going to do to go from inches to centimeters?
1 inch on the bottom,
yeah, 1 inch, and then
2.54.
2.5 4. Thank you.
Right, so we multiply by fractions.
And you do that.
2.54 centimeters is equal to 1 inch.
You have to do that again.
Okay, now what does this do?
You have to do it again.
Why do we have to do it again?
To make it square.
Right, because we don't just have inches up here, we have inches times inches. So this will cancel out one of those sets of inches, but we've got to do it again to cancel out the other set of inches. Now what do we do? I should have started further to the left.
100 centimeters,
No,
or sorry,
we're trying to get rid of what and change to what?
Inches and like kilometers.
We already got rid of inches.
We're trying to read it in kilometers.
We could go directly from centimeters to kilometers. Usually we're going to go from centimeters to meters.
Yeah,
So what's it going to look like?
100 centimeters longer. And then 1 meter on top.
1 meter on top, because that's what we're changing to. 100 centimeters on bottom, that's what we're changing away from.
Okay,
That cancels out a set of centimeters.
you did that twice.
We got to do it again because we got square units here. 100 centimeters, 1 meter. All right, now what do we have to do?
1,000.
Yeah, 1,000 meters on the bottom
Now we got to change from meters to kilometers.
and 1 kilometer on top.
So we put meters on the bottom to get rid of meters. Kilometer on the top, change to kilometers. Okay, that gets rid of 1 centimeters.
Yeah, that's right.
We got to do it again. 1 kilometer over 1,000 meters. Now, if we did this correctly, we should. What units do we have left? Let's see if we did it correctly. What units do we have left? What unit do we have left? Kilometers.
Square.
Yes, square kilometers. Kilometers times kilometers. Is that what we're trying to get to?
Yeah.
Yes. All right, we did something right. Notice every single other unit has been canceled out.
So then can't you say this was like, 2.54 square
Where, yeah.
on the top, and then on the bottom you can do 100 square and 1,000 square?
Well, we're also going to have this.
Well, yeah.
Well, yeah.
Yeah, so we have 28,000, then we just combine it into a single fraction. Times 2.54 squared on top, and on bottom we have
1,000.
100
100
squared
and then 1,000.
times 1,000 squared.
And then you put square.
Square kilometers, right. You don't need to then go and do the, arithmetic there.
Brutal, man.
you don't need to do that.
Mr. Real,
Yes,
on set 44, order and should be.
problem set 44, what page is that? Page 180, question 16. Least common multiple. Yes, this is a good thing to go over because you notice it's from problem set 43. Let's do this one. This is page 180, number 15. 180, number 15. We're looking for the least common multiple. Oh, sorry, 16. Okay, we'll do 16. We'll do 15 also, but we'll do 16 first. Number 16, we're looking for the least common multiple of what?
4 W squared minus Q 6 W Y squared.
Oh, I'm just.
How do we find, with least common multiples and greatest common factors, what's the first step to do to find least common multiples and greatest common factors of 2 or more numbers or terms? Break them down into?
What is it called?
Yeah, what's the term? Anyone remember? Not exponents. Starts with the
What? A P?
prime factors. Yes, prime factors.
Wait, what problem?
Remember,
This is from 44, but it's based on lesson 43. This is on the test. We break them down to prime factors. How can we write 4w squared y cubed as a product of prime factors?
you can write 4.
No, 4 is not prime.
2 squared
2 squared,
Yeah, well,
W squared
times w squared
times y cubed.
times y cubed. 2 squared times w squared times y cubed. And what about 6wy squared?
Yeah, 3 times 2,
Yeah, 2 times 3 times
w,
w times y squared. Now, we're looking for least common multiple. What do we do with these prime factors to find the least common multiple?
so the answer is 2 squared,
The greatest.
You can
then
keep up.
w squared, then y cubed.
Yes, so we have to find the least common multiple. Remember, we're going up from these numbers. So every one of these factors has to be represented. So we have to get 2 represented. We have to get 3 represented. We have to get w represented, and we have to get y represented. Now we have to make sure they're up to the right powers, because we don't just have 2 here, we have 2 squared. We want the highest power in each of them. What's the highest power of 3 that we have?
3, 3, 3,
3 to the first power. Okay, we can leave that. What's the highest power of w that we have? Squared. What's the highest power of y that we have? Cube. You can leave it like that, or for one like this, you might just calculate it out. 12 w squared y cubed.
Well, what test was that?
11. Let's do 15 also.
Oh, I thought that said test 2. I don't know.
No, I for once I didn't use Roman numerals here. Test 11. Let's do 15 also. We're looking for the least common multiple of 8, 30, and 75. Yep, that's the first step here to find the least common multiple of these 3 integers.
First you start factoring with 8.
Yeah,
It is 4
4
times
and
2, which is equals 2 times 2 times 2.
or 2,
I do a tree, and it's like
yeah.
8, 4
Yeah, how else can we write it? 2 times 2 times 2.
2 times 2 times 2.
4,
4
2
and
times
2.
4 times. 2 times 4.
no.
2/3. Oh my god, sorry, 2
Oh,
2/3.
two
Wow.
Yeah, 2 cubed or 2 to the third power. Alright, what about 30? Yeah, you can do the tree if you want for these.
The tree is easier.
8, you should know that 8 is 2 cubed. That you should just, like a times table, you should just know that.
10 and 3.
30 is 10 and 3, 5 and 2. So we've got 2 times 3 times 5. It's always good to go in order with these prime factors. And what about 75? 75, maybe we're going to have to do out, although it actually isn't that hard.
15 and
It's 5
5.
and a third.
15 and what?
5. I think.
Mm,
Oh.
Wait, is that a 6?
25.
yeah, 15 and 5 is right.
Oh,
Yeah, or,
5 and 3.
and then 5 and 3. Yeah, we could also, notice you could also do 75 is 25 times 3, and 25 is 5 squared. It doesn't matter which order you go in these. This is the easier way to do 75. You recognize 75 is 25 times 3, 3 is prime, and 25 is 5 squared. All right. Okay, how do we find the least common multiple once we have these prime
First
factors?
you put 3 times 3 times 2. So first you put
What?
First you put 2 cubed.
We're gonna have 2 cubed. Why 2 cubed?
Because that's in because there's nothing higher than 2 cubed.
Right, so we have to have the 2's represented, and we need the highest power of 2's, so 2 cubed. What next?
Then you have just 3.
Times 3, because we have to get those 3's represented, and then
5 times 2. 5 to the power of 2.
and then 5 squared, because 5, these 5's have to be represented. So we need 5 squared because it's the higher of the 2. 2 cubed times 3 times 5 squared. If you multiply that out, you'll get, what, 75 times 8, which is going to be 600. The fast way to do 75 times 8 is first you double it. 75 times 8 is the same as 150 times 4, which is 600. Okay. Yes, got to know how to do the least common multiples. Let's also find the greatest common factors of each of these. What's the greatest common factor for each of these? So the least common multiple of this one is this, but what's the greatest common factor for number 16? They asked for the least common multiple, but let's do the greatest common factor.
2.
This exact problem,
For the same two numbers, now let's find the greatest common factor.
2 squared.
2WY squared. How did you get that? That's correct.
so those are the three small numbers,
Well,
those are the three small.
those are the things that they have in common. That's everything they have in common. Look, they each have 2, but they only share 2 to the first in common, because this one doesn't have 2 squared. So they share 2, they don't share 3, W, but only W to the first power, because this guy's only W to the first. And then Y squared and Y cubed, so they only share the Y cubed. Because remember, they only share the Y squared, because Y cubed is Y squared times Y. 2WY squared. What about the greatest common factor of these three guys?
You didn't write it.
So the first one, you cross out, we're doing we're doing 16, right?
Well, now we're doing 15. And they're in opposite order.
Oh, it's 3.
What's the greatest common factor here?
2.
No, 'cause you don't all.
Yeah, they do.
Yeah,
Oh, no, they don't.
yeah, they don't all.
4. Wait, no.
It's gonna be like 2.
We don't have one. So, 2, not 2. 3, not 3. 5, not 5. So the greatest common factor is 1. We can always divide things by 1. But those three numbers don't share any common factors other than 1, which is a sort of top out, because you can divide anything by 1.
So much numbers.
About 10 minutes? All right, next. Other things you want to go over. Focused on up to and including lesson 44.
Bro, why? Please turn off.
What's that line from St. Paul?
Right.
About-
Remember the process of translation.
Not worrying about tomorrow
Yeah.
because
No, no,
the
really.
day has enough troubles of its own.
It doesn't
That's
matter
Ant's
what
strategy
day
for
it
his
is.
schoolwork here. Don't worry about tomorrow's test because I've got enough troubles from today's test. All right.
No, I had to write 66 terms, so I didn't really study as much. I studied for like 15 minutes.
We're here to write all those terms. Lesson 49.
Why?
Wait, why?
What?
What? Do you guys have something else you want to go over?
Yes, I should.
All, the rest, the whole book, the whole book.
I would like to go
We
over
can be a little
30,
more specific.
30, question 30 on yes, 48.
48, number 30. Okay, so you need to remember two things about triangles for number 30. What's the first thing to remember about the angles of triangles?
Is it that they all add up to like 180?
They all add up to 180. This triangle looks like this. This one's 140, x and y. Okay, we know that x plus y plus 140 is going to equal what?
480.
180. What else do we know about x and y?
They're gonna be equal.
How can you tell?
Cause, there's, on
The opposite?
the
Opposite?
there's like a tangent. Yeah, that thing. Yeah, so well, I don't know if we did this here, but in Mr. Spears' class, like, we would put an arrow.
Yes?
So it would be the same, and then you'll subtract 180 from 140, then divide by 2.
So notice that the sides opposite these angles are equal to each other. That's what the single line means. They're equal in length to each other. And when the sides opposite two angles of a triangle are equal, then the angles are also equal. So we know x and y are equal to each other. So if x plus y plus 140 equals 180, we know x plus y equals what?
40.
40. And if x and y are equal to each other, That's how you do it. Notice there the tick marks on these two sides of this triangle, telling you that those sides are equal in length, and therefore the angles opposite them are also equal. One of the wonderful things about triangles.
Can you do number 44? Almost number 44.
Nope.
Wow, actually, that was so funny.
No, seriously. What do you mean? I'm not being serious. We haven't done it.
Okay.
Number 44.
Wait, would you read me the problem that you want me to do?
Number 44 on problem set 44.
So bad.
Here's number. Wait, tell me why? Oh, it's on. Never mind. Oh, he did number 17. Number 17.
What page is this?
Uh,
180, number 17.
I
Yes.
didn't realize what that's in the-
Okay, we've got these two fractions. So on page 180, number 17, we've got these two funky looking fractions, and we're supposed to be doing what with them? What are we supposed to be doing with these fractions? Anybody?
Making the actual denominator.
Why would we want to do that?
Well, I mean, sorry, like seeing if it's, or adding them as them.
Yes, we're adding them together. Look, there's that nice little plus thing between them. Yes, they're adding. Okay, in order to add two fractions, what do they need to have?
Same denominator.
They need to have the same denominator. Do these have the same denominator? Oh, that's so nice of them. They already have it. Okay, so once they have the same denominator, which these two happen to already have, what do we then do in order to add fractions? How do we add fractions? Once they have the same denominator, we do what? How do you add 2/4 and 3/4? They got the same denominator.
5/4.
How'd you get that?
So you just add a numerator.
You just add the numerators, and the denominator does what?
Stays.
Stays the same. So we're going to do the same thing here. We're going to add the numerators, and the denominator will stay the same.
3x 5x squared m squared. No, I'm just kidding.
3x plus 4m.
Over.
3x squared m.
Now, how'd you get this thing on the top? Right. Notice, this is what we're doing with the top, is we're adding 2x plus m to x plus 3m. This is all addition, so we can drop those parentheses.
4
And we're going to combine like terms.
and 3.
So m and 3m add together and give us
4.
4m, and x and 2x add together and give us
3x.
3x. Okay, you write 4m plus 3x, you can write 3x plus 4m, whatever. But first we have to make sure they have the same denominator, which in that one we didn't have to do anything to make that happen.
Number 18.
Number 18. Working really hard to kill time here. 18. Yes. Yeah, let's do 18 because 18, we're going to run into some issues. 18. 3 over a plus 1 over b plus 1 over 3. What are we doing here?
You're adding.
Adding what kind of things? Fractions. Anyone remember another word for fractions? Now, a term for fractions in algebra? No.
Division.
Rational expressions.
Rational equation. This is a
Well, this is not an equation.
rational.
Expression.
Is that gonna be an assessment?
No. Just a good term to know. But this kind of thing is, yes. So we're adding 3 fractions together. What do we have to do in order to add fractions?
Make the denominator the same.
Okay. What's the new denominator going to be?
3ab.
3. Where did you get 3ab from? Why is it 3ab?
We already have to do this.
Yeah.
All right. Moving on. Lesson 49.
No.
Open up your books,
No,
too.
because there's a 3, a 8, and a b. There's nothing else. So
Yeah, you look for the least common multiple, then we get 3ab.
yeah. So
All right.
good. I was kind
Good.
of confused.
So let's talk briefly about, yesterday we were talking about polynomials.
No.
Polynomials, which are things that, where each term has the form ax to the n, where it's got a coefficient, a variable, and an exponent. You can have multiple terms in your polynomial. So 4x squared is a polynomial. 4x squared plus 3x is a polynomial. 4x squared plus 3x minus 7 is a polynomial. X is a polynomial because that's 1x to the first. Negative x is a polynomial because that's negative 1x to the first. 6 is a polynomial because that's 6x to the 0. Take the hat off. It's a new rule.
He's scared.
All right. Yesterday we added polynomials together. Adding polynomials is fairly straightforward. We need to make sure that we have like terms. Like terms are things that have what?
Same thing.
The same, what kind of thing?
Same
Same variable with what?
Same exponent.
Same exponents in the same places, either top or bottom of a fraction. Same variable, same exponents, same places. So if we're adding, 4x squared plus 3x minus 7, if we're adding that to 5x squared minus 4x plus 1, we're going to combine 4x squared and 5x squared. We're going to combine 3x and negative 4x. We're going to combine negative 7 and 1. Notice, when we write out polynomials, what order should we always write the terms in?
Yes.
And I've done that with each of these here.
Same order.
What order is that?
It's the
The descending order of the variable, descending degree of the variable. So notice we start with x squared, we go x to the first, and then x to the 0. Always going down. If we had x cubed, that would come before x squared. All right, we're out of time. But in lesson 49, there's going to be a discussion of multiplying polynomials together. Well, the test tomorrow, you can get here as early as 8:30 and start on the test.
No.
We're going out. Wow, that took you a lot.
Yeah, surprisingly.
It's because the hair is spiky.
And then it's true. It's like really short, and it's sort of like
Yeah.
I love that feel.
What?
Whoops! Somebody had a